Okay, hello. Welcome back. Part 11 today of me trying to implement a WebAssembly interpreter in Ruby. I'm going to run through this intro, what some people might refer to as a process or a ritual, or others might refer to as a rigmarole. I'm just going to go through it. I'm doing this to have fun, reminding myself that this is supposed to be fun. I'm hoping to demystify WebAssembly for myself, and today there is a chance that that will begin to happen because we might actually start doing some WebAssembly, so that'll be exciting. And I also just want to work in the open, share how I'm doing this for better or worse. This is how I do stuff. It's more important that I have fun than that we end up with a fully functional WebAssembly interpreter. It's more correct than fast. I would rather have something that does the right thing than something that's super performant. It's more clear than clever, ideally. I want the code to have sort of obviousness and clarity so that I can understand it and hopefully other people can understand it. I'm trying to get this done in pure Ruby, and I'm trying not to use any dependencies. We have so far survived. We'll see if I get to the end of this one without having to break either of those rules. So as always, brief retrospective now that I've had a chance to think a little bit about what happened on the last stream. Firstly, I think that floating point numbers are working now. I had a horrible rounding bug yesterday. Oh, hi, Chris. Welcome. We're just about to talk about you. Had a horrible rounding bug yesterday. It turned out to be, although it was horrible, it turned out to be fully explicable and very easy to fix. So it could have been much worse. If the code had been harder to understand or to change, it could have been much more of a nightmare than it was. And so that feels kind of like a vindication of my bloody-minded desire to do things in a principled way. Like, it meant that I didn't have to change loads of code to be able to fix that bug. It was just a very targeted fix. It took me a little while to understand what the problem was, but once I understood the problem, I could just fix it straight away. So that was that feels like the most payoff I've had so far of the approach that I've taken to working on this. So, I mean, I suppose, a slight moment of celebration that floats are working. It's tempered slightly by the fact that float exprs.wast file is still not parsing, but it looks like that's because of other missing language features, like the memory thing is what it failed on at the end of the last stream, rather than anything inherent to floating point numbers themselves. So I'm sort of taking that win. Oh, what's Chris saying? Let's interject Chris's comment into the retro. He said was thinking about the floating point bug he came across yesterday. If it makes you feel better, I looked at the OCaml reference implementation and it also had a hard time representing low-level floats. Okay, great. Well, that is a comfort. Thank you, Chris. I appreciate knowing that. And it's not just me then. Right. Test runner. I'm really, really delighted with the cosmetic improvements to the test runner. Like, this now is just so much nicer. Like, it's genuinely a pleasure to run this and to see it run. I know it's a small thing, but to me it feels like a night and day difference for the test output to like not be painful to interpret, and also making the parser incremental, even though that was only a small change because of Ruby's good language features, because it was very easy for me to make the parser incremental rather than have it return the whole S expression at once. Makes the tests feel faster as well, even though they're not really. There's just less waiting while nothing is happening, and to me that's like immensely psychologically valuable. So that's just pure celebration. I'm really happy about that. I'm really glad in the end I spent, I think, over half an hour fiddling about with that test runner and putting the colors in and making the parser incremental and all that stuff. But like, I feel like that's the most bang for the buck I've got on anything so far, so I'm really happy about that. So on the last stream, I was very conscious all the way through that my brain wasn't fully working. I think I was just very tired. I hadn't had enough sleep. But the consequence of that was that I was sort of stumbling over my words. I made lots of silly mistakes again, and I wasn't thinking clearly at several points, which obviously isn't great. I mean, I'm glad I can still make progress in that state, but I was just very aware that I wasn't at my best, and going back and just sort of clicking around in the stream and watching myself, I just found myself thinking like, mate, you just need to go and have a nap. So I, you know, it's just not good. But today I'm better rested. I have had a nap. And I think the reason I'm talking about this is that I want to make a conscious effort to just focus more and not be so careless. I feel like I've made a few careless mistakes, or I've sort of got confused unnecessarily. And I think if I just focus and allow myself to step back and take a breath, it'll be fine. But yesterday, I think I just went down a couple of rabbit holes, and I sort of got frustrated and distracted, and emotionally, I wasn't in the right frame of mind to be able to see the simple solution that was right in front of me. And it's kind of frustrating to realize that's been happening. And so, yeah, I tried to get some more sleep, and I'm going to try to be a little bit sort of calmer and more centered today, and try to not make so many silly, unforced errors. Right, maths. Here's an example of me not being very attentive. Chris had a really smart suggestion about using the sign of an exponent to avoid a conditional when we're computing the value of a float. And that is exactly the sort of principled thing I want to be doing. But when he suggested it, I was just sort of too sleepy and distracted. I was trying to do something else, and I sort of didn't give it my full attention. And I just didn't properly... I sort of briefly tried it, and it didn't immediately work, and I just kind of, huffed and gave up and moved on. But I think it was a really good idea, and now that I'm a bit better rested, I want to take another bite at that apple. So at the risk of further prolonging the work on floats, I do want to prioritize going back and looking at that today, because I think it would be super satisfying if I can get it working. And besides, who doesn't love some maths? So let's get into it. So here's the state of affairs. I mean, firstly, if you hadn't already seen this, you can see that I've made the output of the test runner way less noisy and way nicer, and it does feel a lot snappier because of incrementalizing the parser. So now the work of parsing is spread out between all of the green dots rather than being batched up in one go before you even see the first green dot. So that's really nice. The test that's failing is complaining about it doesn't know what this memory instruction is. So let's just briefly GitHub. So yeah, this is in the float expressions .wast float expras. So where's this memory 1.1? Okay, so we're getting we're getting a reasonable way through this. That looks like a fair number of assertions. It's about a third of the way through this file. So a lot of good stuff has happened. I mean, unsurprisingly, apart from that one bug, it has not managed to find any place in which I'm incorrectly doing an optimization. Don't worry, acceptance tests, there's not very much chance of that. But you can see here, for whatever reason, we haven't seen this piece of syntax before, and so the interpreter's just choking on this, and we're not even getting a chance to evaluate these functions that are defined down here. So I am now being forced to move on to implement some of these language features. I mean, I don't have to keep trying to make this file work. I could just sort of push something else onto the stack. In particular, well, I'm going to come back to this in a sec after we've looked at the Chris thing, but I think, there's probably, I mean, actually, now that I haven't actually read this, but I can see that there's memory here, there's F32 store here, there's local here, there's block here, there's loop here, so there's if. So there's actually quite a lot of, these are control flow instructions, and then there's local variables, which we haven't seen explicitly before. We've only seen function parameters. And then this presumably is storing in the memory. So there's actually quite a lot of language features in here that we haven't seen before. So I think perhaps rather than try to charge through this without knowing what any of these instructions do, now it might be necessary to take a detour into like, how do we implement, well, all of these things. How do we implement memory and F32 store? And is there an F32 load? Yes, F32 load. So I can sort of see that memory and store and load might be a single thing that we could get working. And then I think local is a feature that we could add to function definitions. And then there's this control flow stuff, block, loop, if, I assume that's break. So yeah, I can see at least 3 distinct categories of language feature that we're going to have to implement before we can continue with this file. So it might take a while before we get back to this. But yes, so I think I'm all good here. The thing that Chris suggested, where was it? In float.rb. So it was one of the uses of sign. I was complaining, as always, about, like when I made, as I've sort of reified some of these concepts, so as we've gone from having a separate numerator and denominator to having a rational, and as we've gone from having first no concept of sign or a Boolean, and then an integer, and now we've got a sign class, I've sort of been able to tidy up some of this, some of the implementations, take out some of the conditionals. And what Chris suggested, I can't remember if it was this one or the other one, I think it was this one, but there are 2 such. There's this one here in decode, which is, well, in order to construct a float, if you know what the exponent is, what you have to do is do 2 to the power of the exponent, and then you have to either that exponent goes in the numerator or the denominator, depending on whether the exponent is positive or negative, right? So that logic happens here in decode, and then in parse immediately below it, there's a sort of similar but different version of the same idea, where again we're trying to get the number that we want to either multiply or divide the fundamental rational number by the significand. And Chris suggested that that basically this division or multiplication could be represented as raising to the power of a positive or a negative number, right? Because if I raise something to the power of 5, then hold on. If I multiply by something raised to the power of 5, then that is going to make it larger. If I multiply by something raised to the power of -5, it's going to make it smaller. So I suppose the question is, well, I mean, maybe the more instructive, I'm derailing myself with bad examples. Let's think about 2. If I multiply by 2 to the power of 5, then that's going to multiply by, what's 2 to the power of 5? 2, 4, 8, 16, 32. It's going to be multiplying by 32. Let's look at it in IRB. So 2 to the power of 5 is 32. Phew! If you do 2 to the power of -5, it's 1 over 32. It's the reciprocal of 2 to the power of 5. And that's just a basic property of exponents. But as Chris is pointing out, that multiplying by, and I suppose in this case, we're talking about the sign, so 2 to the power of 1 versus 2 to the power of -1 kind of becomes, this does the division just by using a property of exponentiation without us having to do this division and multiplication ourselves. And I think I did understand that that's what you were suggesting last time, Chris, but like somehow when I sort of sketched out an implementation of it here, it didn't immediately work. And so I just kind of, because I was trying to do something else at the time, I didn't come back to it, but I think we should come back to it for at least, 5 minutes and try and get it working. Welcome, Tom. Yes, well, the floating and pointing is hopefully almost over. This is the last bit of floating and pointing that we're going to be doing. So hopefully this will be mercifully brief. So I think the point is that we could do, well, let's try and do a manual version. I just want to I want to creep up on this and see, because this thing divides or multiplies by scale depending on whether the exponent is negative or positive. So what Chris was suggesting, I think, was that instead of that, we could, because I think this scale, well, it's actually not going to be a rational number because it's being, hold on a second. I was about to start talking about we could multiply scale, or we could raise scale to the power of the sign of the exponent. I think this is what I tried to do last time, and I refined integer in in sign conversion to make it possible to do this, because exponent here is just it's just an integer, I think. Yes, it is. And then we could multiply, and then this would either leave scale alone, or it would take the reciprocal of scale, depending on whether the sign is +1 or -1. And then instead of doing this conditional division or multiplication, we could just do, rational times equals. Well, I mean, I guess actually these are independent, so it could have just been rational times scale times sign. Well, I mean, I'm not going to go. I've just realized that we're taking the absolute of the exponent here, and this already contains the sign of whether it's positive or negative, so we don't actually need to do this, but I'm just going to try and, so if exponent is positive, then 1 or -1 is what I was talking about there. So does this at least pass the tests? No, because I can't do Ruby. I still can't do Ruby. What on earth? Well, my spiel about being more awake and not making silly mistakes is not panning out, is it? Okay. So that's pretty convincing, I think. I mean, we could wait for that to finish, but I think it would have failed by now if this way of decoding floats wasn't correct. So I think this is already great, because it means I've got one fewer conditional, and I'm sort of relying on, maths rather than, yeah, there we go. This is, of course, I've added something to the to-dos here, where I find it difficult at a glance to pay attention to this green text that says pending test failed successfully. I see this red up here, and I think it's a real failure. So I would quite like to be able to turn off colors for pending tests, but maybe we'll do that in a minute. Anyway, I really like this. I mean, Chris said that he thinks this is less clear, and that may be so, but on the other hand, I think that this expression that we're starting to write here is becoming very close to just an explanation of how you construct a value from its encoding as a floating point number, right? You take the significand, and this is not quite right, but you multiply it by 2 to the power of the exponent, and then you have to apply the sign. I mean, whether we should be pre-multiplying by the sign or whatever, but ultimately this is the recipe for putting together a float. And actually what I was doing before, I think, is more obscure than that, because now you're having to think about numerators and denominators and all that kind of stuff. This is starting to feel like a more natural treatment of the exponent. And actually, if I can just, instead of separating out the sign of the exponent and the magnitude of the exponent, 2 to the power of the magnitude of the exponent, and then to the power of either 1 or -1, depending on what the sign is, that's the same as just not removing the sign in the first place. So if the exponent is -5, then scale here is just going to be 1/32. And before I had to treat them separately because I needed that conditional to be able to choose whether to multiply by or divide by the exponent. But that was, I suppose what I had missed is that was an artifact of a bygone era where we didn't have operations on rationals, and now we do have operations on rationals. So I think I can just do this. And in fact, I think I can, well, let's run the test. But my belief is, yeah, again, pretty convincing. I think that this can just be inlined here. And we can say that the value of this decoded float is the significand times 2 to the power of the exponent times the sign, whether it's positive or negative. And that is exactly the recipe for how you compute the value of a float. So I think this is actually, in fact, I would even be tempted to inline this because it's concise enough that I think this just expresses exactly what we want. And I think this is the clearest. This is to me much clearer than what we had before. This thing with the conditional and everything, and like it's both concise and, you know, clearly correct in my view. He says before running the tests. Let's see if my hubris is going to be punished. Nah, looks like it's fine. So I think that's amazing. Can we do it in the other case though? I actually hadn't, although I thought about this a little bit and realized that Chris was onto something. I hadn't realized that we could also stop taking the, you know, that there was actually even more we could do here. That scale argument goes away altogether. We can just use, and it's very fortunate that Ruby has this behavior, right? That, because I don't think this is a foregone conclusion that we would necessarily get a rational here. We might get a float. And I think if this returns a float, it would not work, or at least there would be a risk that there'd be some kind of rounding error or something. But because this is irrational, we get all of the same behavior that we had before with respect to changing the numerator or the denominator. Like, I don't think there's any loss of fidelity here at all. So Chris is saying it feels like sign should go first in the expression. Yeah, you're probably right about that. So how do I make that work? Because I think that isn't going to work out of the box. In fact, how about I make this work? Because I think if I try and pre-multiply by sign, it's going to complain about multiplication not being defined on those instances of the sign class. Yeah, there we go. Undefined method star for sign. So I'll leave it as it was for now so that I can commit what's already quite a significant change. And then I'll just do a little tweak at the end to implement multiply for sign. So what's this version of that change? How does that go? So this is that same scale thing. So here the exponent sign is legitimately separate. Like, exponent sign is actually just a string here. And we turn it into an instance of the sign class by looking it up by name. So yeah, again, I'll take this a step at a time. So if I multiply rational by scale, if I have, I want this exponent sign, right? In fact, why don't I just pre-convert it up here? Because that's where I'm doing it here. Sign, exponent sign, map, sign for. I really like these nameless block arguments or whatever they're called, but I wish that if you've got a block with only one argument, I wish you could just call it underscore, because I think that's much more pleasant. But unfortunately, that's not how it works. So we're just stuck with this slightly ugly syntax. So if I've already got the exponent sign, so if I do scale to the power of sign, will that work? Oh. Expected one, got something else. Okay, well that's clearly not working. Okay, so what about if I'm not sure what's going wrong there. Let me break this apart. So the rational's already being multiplied by its sign here. So how about we say exponent equals this. Oh. And then that's... So if I raise this to the power of exponent sign... Sorry, again, I can feel my brain kind of giving up the ghost here. So we get sign instances for both... Oh, it's because... Just not thinking properly. Okay, that's why it wasn't working. It's because I got that variable name wrong. Okay. All right, well, what I had before was probably okay then, but let's just carry on with this. So this is all just like converting the strings that have come out of the regular expression, right? So, and sort of hydrating them into meaningful objects. So the sign and the exponent sign, we run them through the sign factory. The exponent, we have to use toInteger and give it the right radix and allow it to default to 0 if the exponent was not present. And then we raise that to the power... Well, that's not right, is it? No, we multiply it by the sign of the exponent. Right. Signs are multiplied by. Exponents are... Yeah, I mean, we could have done this in 2 separate stages, but I think this is... Okay, I'm going to get... This code is just confusing me, so I'm just going to comment all this out. So we've got the sign of the significand. We've got the sign of the exponent. We've got the exponent now, and that is now a signed number. Well... Yes, it's going to be positive or negative. Right. So exponent here might be -5. And then I suppose by analogy with what we did up here, which was the rational times 2 to the power of the exponent times sign, we just want to do the same thing here. So we've got the rational here. We want to multiply it by... So where did the 2 to the... Oh, that's what base is. I was like, how do we know what... Why is there no 2? It's because of this. So it's base to the power of exponent and then times the sign. Is that right? And then return... Well, this line was previously higher up, but I think this is still... legitimate, right? That like maybe we've done a little bit more work than necessary here. We could have found out, because if the result of par's rational is 0, then the result of par's rational times some number times the sign is also going to be 0, but it doesn't do any harm for it to happen after that. And I would say there's a benefit in having this sort of regularity here that's like, well, it's sort of modularity, right? Like here's the module of code where we take the strings and we decode them into the rational, and then this is where we look at the value of the rational and say, well, if it's a 0, then we want to return an instance of the 0 class. Anyway, does this even work? Yes. All right. Well, I'm just going to assume that that's all fine. Well, I'll check back in a sec if not. But so now, I mean, well, this is just a conditional now. And it's always nice when you can remove a return, right? Because now I've got straight line through control flow. Previously, I had like an early return here, which I think always makes code more difficult to understand. I mean, if it's a guard right at the beginning, then like maybe that can be okay. But it's still a sign that you haven't got like a nice general solution that can run top to bottom. And here, I think now we do. There's this whole section here that's decoding the rational from strings, like I said, and making use of, again, the existing multiplication by the sign of the exponent, this sign object. And then we just say, well, we just choose what class to return based on... Oh no. What's this? Dynamic constant assignment. What the heck? Maybe that was... Yeah, I'm not sure what's going on there. Let's just let this run. It's such a pleasure to watch this run now. I could just watch this all day. These green dots are hypnotic. Okay, I don't know what was going on there, but I think maybe it was caused by me like saving this in a wonky state, because this the shell script is like re-invoking the Ruby interpreter over and over, and so maybe I got this in a weird situation. But I think, I mean, that is, to me, that is such an improvement. So Chris, I think you deserve all of the credit for suggesting this in the first place. I, wasn't paying attention to the fact that this is clearly the way to do it, and the opportunity to use exponentiation with a signed number had just completely eluded me. Or I missed the opportunity to do that once we switched to using... Well, first when we switched to using an actual rational instead of separate numerators and denominators, and then again when we moved to using this sort of reified representation of signs. So I'm very happy about that. Thank you very much. So what's the... well, let's just say use 2 to the power of exponent to scale a rational per zeta. Idea. I don't know there's much to say here. This is a much more direct translation of how to assemble a number from its floating point components. We couldn't do this originally because we didn't have instances of float and sign to hand, and not float, rational. But now that we do, it's much clearer than messing around with conditional division. Yeah, an excellent bit of backseat programming, Chris. Well done. Thank you, Chris, for suggesting this. All right. And then, yes, okay, the other thing you wanted was, at least for some of these, for the sign to be at the beginning. So you felt like we should... that the expectation is that the sign goes first. Sign times... I mean, the question is, do I agree with that? I mean, I'm not entirely sure that I do. How would you feel if it was, if the multiplication by sign was happening inside here? Does that... I mean, that's closer to the front. I suppose I just feel like... I mean, obviously the sign does go at the beginning, but I just feel like in that product... I don't know. I feel like the big important thing should go first, and then if we're just flipping the sign of it by multiplying it by 1 or -1, or if we're scaling it up or down by multiplying it by 2 or by a half, it feels like that kind of needs to be stuck onto the end of it rather than inserted before it, even though, of course, when you write down a number, the sign does go first. In a way, this kind of putting significand times sign inside there, I do actually quite like. But here we can't do that. At least I don't think Parse Rational supports it. Well, I mean, it's not really any trouble. It's just a question of whether, I mean, maybe you mean the trouble of me not instantly agreeing that that's the right place for it to go. How does this work? Oh, these are all strings. Okay, well, I'm not going to get involved in that. I think I'm going to do my classic maneuver of saying that I'm going to leave it for now and come back to it later. Is it nicer and or clearer to pre-multiply by sign instead of post-multiply when building a float value in decode/parse? So yes, I shall revisit that. I think I need some time to think about it. Right, great. Did I have a... I must have made a to-do for this. This to-do list is getting too long. Oh yes, think about using rational... Yes, there we go. Boom. I think before I move on from this entirely, I think this... Now that we've been talking about the various benefits of using rational, I feel like the one remaining place is in this approximation class, right? And I just can't think of any reason why we need to have separate numerator and denominator here, like have to do this work here to separate out the numerator and denominator. It's just silly. So let me see if I can quickly change this. So I'll just say rational instead of numerator and denominator. So this will just be rational. It does still need to be the absolute value of the rational, I think, because none of this code, at least in its current state, none of it is designed to use negative, to deal with negative numbers. It might magically work, but I don't want to tempt fate that much. So this takes a rational. Here, well, I don't like that. We should probably expose the quotient. Yeah, these should be private. I think I had a to-do about this. Yeah, make internal approximation methods private. Well, while I'm in here, why don't I define quotient here to be rational numerator divided by rational denominator. And then up here, this doesn't have to be such a train wreck anymore. That can just be quotient. Oh, this is small enough to stick on one line, I think. So now we're just passing the magnitude of the rational in. This thing needs to know... can I just do self quotient here? I know that this is going to be needed again, so I don't just want to keep calling it. Oh, it's not even really it's not really a problem, is it? Let's see if I can make this work. So if the quotient is less than the minimum quotient and the exponents include exponent minus 1, so this was the numerator and the denominator get. So this is scaling up. So now this is self-rational gets multiplied by 2, which is, of course, what this was doing. But now we're thinking of it as a rational number. So we're not sort of shifting an integer left. We're saying like multiply it by 2. And again, there's another magical 2's cropped up here because this is all hard-coded assuming that the base of the exponent is 2, which I don't feel brilliant about. And in fact, I think I had here, make exponent base explicit in approximation, but we don't intend to ever support any bases other than 2 for floating point numbers, so it's not a big deal. Likewise, this one becomes self.rational is divided by 2, I think. So I think that's it. Does that work? No. Oh. Where's that? Oh, right, yeah, of course. I didn't scroll down to this other method. Quotient remember it equals numerator div mod denominator. I'm not quite sure what to do about these, about this being available in a helper method. Probably doesn't matter. I'll just ignore that for now. Oh, and of course this here, where this sets the numerator and denominator, instead what we're going to do is set rational to be, well, it's just this rational. We don't even need to specify the denominator because 1 is the default if you provide, well, it's the correct one if you provide an integer. Maybe I'll put this back. Like this here is part of the public API that faces the client of fit within. It's not really intended for consumption in here, and the fact that I can call it, it's not symmetrical with what I have to do here, which is use div mod to get the quotient and the remainder. So I think I'm going to leave that alone. Oh, for goodness sake, what is wrong with me? So here I have to explicitly be talking about the denominator. That line's getting very long, but okay, that looks all right. Can I break that? There's not really any good way to do this in Ruby. Maybe something like this. I mean, at least it doesn't, at least it's not a huge long line. Okay. Well, I think that's working. I actually, again, I do sort of like this more. I know we've gone back into doing division here. But I think this is a nicer encapsulation of what's going on. You know, one of them is, yeah, essentially this is saying the rational is being multiplied by the base, and this is the rational is being divided by the base, and then the exponent is being adjusted to compensate for the fact that we've modified the quotient in that way by either doubling it or halving it. So I think that's quite nice. I could just return approximation from this approximate within. But then I would just have to call quotient and exponent on it to get these. So I think the fact that this is projecting these two parts, these two relevant values out of the approximation happens within this helper, I think is nicer. Yeah, so I think I'm gonna leave it at that. So what am I gonna say here? I suppose this is just use rational in approximation. Well, use rational instead of separate numerator, denominator in approximation. We're using rational everywhere else for this purpose, and there's no reason to not do that here too. So let's do it for the sake of consistency. It doesn't really make it better. I suppose it makes it have fewer fields or whatever, but it's not like it dramatically changes the the nature of what we're doing there. Just trying to think whether there's anything else that's worth putting in that commit message. I can't think of anything. No, I think that's fine. When I was looking at this, I noticed this. I don't think we need this because we've got this getter now. So I think I can also remove that. While I'm in there, yeah, I believe that that's fine. Remove unnecessary sign local variable from wasminer float finite encode. Now that we have a sign getter, we can just call that instead. And it's only being used once. It's just retrieved when we actually construct the appropriate representation of the float, so it's not like we need to cache it performance or anything. Okay, so use rational in approximation, I've done that. What's this use sign in finite encode? I am using sign in finite encode. So I don't know what that's about, but I think I'm doing it. So I'm going to say that that's done. Is there anything else I want to look at while I'm in here? Oh, one thing that I noticed I did last time, again, this was a symptom of me not having my wits about me, was that when I was debugging this problem with the float encoding, the rounding of integers, I wrote out this longhand example here, but I think this is just an instance of assert float encoding. That's what assert float encoding does, is that it calls it calls encode from integer. Well, I could just as well be, this could just as well be finite new, and this could be rational, and this could be with an R on the end. And then I think that really is the same as that unit test. Although I didn't actually know what the correct encoding of this was. So I'm just going to do this so that this isn't because otherwise I'll never get around to doing this. And then after this, I'm gonna crack on with the memory locals stuff. So why don't I find out what the correct encoding of this is, and then I can use assert float encoding for it. So if I take this number and treat it as a double, and then unpack that as a quite long number, and then ask for that in hexadecimal, then that is the encoding. And let's double check. If I pack that as Q, unpack that as D, I do indeed get 6723 bar 4377. Okay, right. So that's the encoding. I quite like having these written as hex. And this was the thing being encoded. And I think that does the same. Yeah, well, I mean, I think it does the same. I am sufficiently convinced of that that I'm just going to whack it in there. Yeah, the only difference is that now I've pre-baked what the correct encoding is, whereas before I was determining the correct encoding by running it through pack and unpack. But I think this is a nicer way of expressing the same idea. What was my to-do list item? Yeah, use assert float encoding in float unit test. I'm just going to say that. Oh, silly. This is essentially what the previous code, which I wrote in anger while trying to debug the problem, was doing anyway. So it's better to use the existing assertion. Well, it's clearer, much clearer to use the existing assertion. All right. I mean, I think these unit tests are a bit unloved, but that was just a silly oversight on my part, so I'll clean it up. I think all of the rest of this is quite... I may yet come back to all of this stuff, but this is all a bit speculative. I don't think I'm going to do this because this was predicated on needing to do stuff to make converting between Booleans, negated Booleans, and signs easier, and I don't need to do that anymore because I've got that sign class. Exponent base, break it into separate files, rounding, regex. Yeah, that's all. It's all cosmetic. This is sort of performance related stuff and tidying up. This is about tidying up integer operations, so I can leave that. Pending tests. More complaining about unit tests here. I'll come back to these after I've done a bit of interesting stuff. I'll come back and do some tidying up of the test script, I think. But for now, I feel like I haven't really earned that. I need to do some proper work first. So, one more time, let's remind ourselves what's not working. Well, I remember it was this it was this memory 1.1. In fact, like I said, if we want to run through this, we'll need to get memory, and I think store and load are related to the memory. It would make sense. Working. We'd have to get locals working, and we'd have to get block and loop and BRIF working. So we should probably pick... So there's separate tests for block and BRIF. So is that going to mean that they're smaller and easier to do? Well, this one depends on memory. So that's no good. That's not going to get us closer. I have to... Memory is on the critical path to both of these. This one depends on block. So this is even worse. This is on the critical path to... Well, the other two are on the critical path to this, so that's no good. So what about just memory? Oh, and I guess local. Okay, memory. Oh, there's a lot of memory related tests, which fills me slightly with dread. And here we go. Local get, local set. I don't know what local t is, but let's just look at local get. Local get x. So here the local is I. Yeah, local get I. Okay. So memory.wast. So I mean, we need to look at the spec, but I assume that what this is doing is declaring like segments of memory. I don't know what these arguments mean. Maybe they're addresses or sizes. I mean, they looks a little bit suspicious, like they might be the size in bytes or pages or some other unit. I don't know why there's two of them. I mean, this does look lower level than, well, certainly, you know, the other things we've looked at depended on this. So this is more promising, although for some reason I do find it a little bit intimidating, but, you know, this looks potentially doable. How do locals work? Local.get. So I would imagine that, oh, I was going to say that we'd already do some of this, but we don't. I can see that this is new. So even though we use local.get to fetch the parameters, right, so that's what this is showing, is like we've already got this implemented because everything needs this. Everything needs to be able to get the first parameter by using local.get0, or getting a named parameter by using local.get $, whatever the identifier is. But this is suggesting to me that there's a separate thing where when you declare a function, as well as declaring parameters, you can declare local variables, I assume is what they are, and then you can fetch those using the same instructions. So params and locals get sort of smushed together into a unified like namespace, and are treated the same within a function, is what this suggests to me. Oh, we haven't seen this syntax before either, that you can, I assume this is declaring multiple parameters. So this is smushing together 5 parameters and then 4 locals. And then this goes, right, this goes up from 0 to 8. I don't know what drop is. Okay, well this looks like it's going to be either this or memory, right? Does either depend on the other? Right, well this one doesn't seem, this one only has functions that have parameters. It doesn't have functions that have locals. So that's, we could, there's a tick in that box. We could attack it from this end. What about this one? Does this one use memory? No, so we could also attack from this end. Oh crap, but this one's got blocks and burr if and stuff in it. Well, I think there might be a little bit of a cyclic dependency here in that case. I'm not entirely sure. To be honest, this memory one seems like it has the fewest dependencies, like because even the local get test, I mean, we could make a start on it. I think this would be quite easy to get passing, so I could make some headway into this, and I could imagine implementing this sort of multiple parameter syntax. But I can just see that we're going to quickly hit these, because they want to test local variables as parameters of control constructs. Like, we're going to need to support blocks and loops and things. So I think I've convinced myself that this is where we will start. And I suppose just see how far we can get. like I say, I don't really know what this is or how this works. Oh dear. This might end up being quite a deep rabbit hole, I suspect, but this whole project is one bottomless rabbit hole, so I should just make peace with that, shouldn't I? So what do I want to do with this pending test situation? Because if I'm going to start working on the memory, then really I should put the memory in here. I suppose it doesn't really matter because I'm not really going to... I was going to say it's going to be annoying to see the output of both of them at the end, but I don't think I'm going to be running this very often because it takes flipping ages. So I think probably what I'll do is just run this memory.wast on its own, and then it doesn't matter that we get both of them at the end. Now I suppose I should think about conceptually do I want to see... I'm trying to think whether I want it to be at the beginning or the end. I think maybe it should be at the end. Should it? Does it matter? What do I want to see at the end of these tests? Like, what's the last thing? Okay, maybe my first instinct here was better. That I kind of like the idea of pushing stuff onto the front of this, and then potentially popping it off when we're ready to go back to float expressions, and then pushing something on the front again, I think. Or should it be more like a... I can't decide. Certainly, if the reason I'm working on memory is because I'm trying to get float expressions working, then maybe it makes more sense to pile these things up on the end, and then the last thing that I see at the end is like the most relevant thing, which is the thing I'm currently working on, and then all of these other prerequisites, or whatever the opposite for prerequisite is, all of these things for which memory is a prerequisite will also be getting checked, but it's ultimately this last one that I care about. Yeah, I think I prefer that. I think, especially as these take longer to run and I switch away and do something else and then switch back, I think being able to see the one that I'm currently working on showing up last is probably the most useful. So I'll add that. Add memory.wast to test script, and I think I'm going to say a little bit about that. Other contenders, we can't make progress on floatexpras.wast until we have several other language features, including memory. Other candidates included local variables in function definitions and control flow instructions, e.g. loop, brif. But those look like they themselves have more dependencies, whereas memory.wast appears to be fairly self-contained. So we're going to start with that. In the hope of limiting the maximum depth of the rabbit hole. Okay. Great. This has been a long and potentially tedious run-up to me actually doing the thing that I came here to do, which is looking at memory. I mean, it's fairly par for the course that I've spent the first hour just faffing around and doing displacement activities to avoid doing the thing that I knew that I was going to need to do. Okay, so let's get just this test running. Uh, 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 memory. Yeah, like I say, a bit intimidating that there are so many memory type things, but just have to see how we get on. Okay. Right, so this is complaining that it doesn't understand this. That's fair enough. At the moment, we just have module binary, which we ignore. So hold on. You know, the temptation is to say in module, you know, something like that. But I'm pretty sure that this is just one thing that can appear inside a module. So these are all assert invalids anyway, which I haven't really thought about implementing yet because I don't have any way to throw these exceptions. Just look at this. What is this saying? So apparently there's a way to initialize some memory with some data, I guess. Like this is saying that I assume that this string is like the contents of the memory. Oh, these are all assert invalid. Hopefully this one isn't. No, okay, so this looks more meaty. This is the kind of thing I was talking about, is that it looks like memory is just another, a thing that is a peer of func, basically. And it seems like we're going to need data as well. I don't know how we access these. I don't know if they just get... Like this one, it's got data in... This data expression is inside the memory expression. Whereas down here, it's separate. Okay, well, I think I'm going to need to read the specifications, which is something I've been so far sort of strangely reluctant to do. Okay, well, I'll stop speculating and just get on with making... What I want to do is just grind forward progress on this, right? I'm doing a little bit too much thinking here. So this is like memory something. That's what we've got there. Oh, right. So actually what happened is it had gone into this. Oh, maybe I can... Having said that it's just a peer of func, maybe there's no harm in just dropping it in here instead. I don't have to repeat module up there. I can just say in... Does this at least get me further? Ah, yes, it does. Okay, so this can be one or two things. Assert return, invoke mem size. Okay, we don't know how memory.size works. Okay. So this is expecting... Yeah, actually, you know, I guess we need to tell the difference between it being given numbers and it being given an arbitrary expression here, because this data is clearly important somehow. So maybe that's something that I should... Maybe that should be the first case, is there some kind of that? which I think this is gonna, yeah, so it does, we can spot that. Okay, so now we need this memory size instruction. So clearly in this case it's supposed to return 0. That should be easy to implement. So return local get. I think I'm gonna put these memory things at the top, because all of this integer and floating point operation stuff goes on absolutely forever. So let's just stick stuff at the top here to make life a bit easier for me. Memory.size. Looks like that's just a unary operation. Return 0. Hey. All right, so in addition to our pending tests, which are these two, because we don't know how to do assert invalid, we've got 2 passing tests, because memsize has returned 0 as expected. Now this one has to return 1. So I think this is going to necessitate actually understanding what's going on here. So let's have a look at the spec. Structure. Memory types, memory instructions. Let's look at memory types first. Memory types classify linear memories and their size range. Mem type is limits. The limits constrain the minimum and optionally the maximum size of a memory. The limits are given in units of page size. Okay, and what's the page size? Oh, okay, so we're inside runtime now. Runtime structure. A memory instance is the runtime representation of a linear memory. It records its type and holds a vector of bytes. Sorry if this is too small, if you're watching this on the sofa. Oh, well, now we can't see it. Sorry. I hate tiny text, so I can only apologize. The length of the vector, so an array, is always is a multiple of the WebAssembly page size, which is defined to be the constant 64036, abbreviated 64 kibibytes. Well, that feels like something I'm going to need to know. Why don't I just write that down? Isn't that... Yeah, I think that'd be a nicer way of writing it. Okay. The bytes can be mutated through memory instructions, the execution of an active data segment, or by external means provided by the embedder. It is an invariant of the semantics that the length of the byte vector divided by page size never exceeds the maximum size of the mem type if present. So I guess what this was saying is that when you declare a memory, you have like a minimum and a maximum size. Let's see what else there is about memory instances. Oh, that's what we were just reading. Memory instructions. MathJax. Oh no. Okay, this is all a bit involved, isn't it? Hopefully this is just saying the obvious. Oh goodness. Well, okay, we can probably guess what memory size does. Here we go, memory.size. Let f be the current frame. Well, we haven't got anything called a frame at the moment. Assertions. Let a be the memory address. F module memory address is 0. Oh, goodness. Let mem be the memory instance. Let sz be the length of mem, data divided by the page size. mem.data divided by the page size, push the value onto the stack. Okay, we don't even have a stack yet, but it seems like what this is saying, I mean, unsurprisingly, is that this instruction tells you what the size of the current memory is. I don't know how we deal with multiple memories. Clearly these memories are a place to store data, but I just don't really know how. So maybe I need to look at the text format to find out what this stuff means. Memory instructions. This is all loads and stores. This was memory size, which is what we were just looking at. But what's this? Is this like is this like a module instruction? Modules. Memories. Memory definitions can bind a symbolic memory identifier. Well, I don't think that's happening. A data segment can be given in line with a memory definition, in which case its offset is 0 and the limits of the memory type are inferred from the length of its data rounded up to page size. Oh, right. So I think it said before that the memory size thing was like in units of pages. So that mem size instruction, I should have been paying attention. But I think this was saying it tells you the size of the memory in pages. Oh, the hypertext of this documentation is absolutely awful. This here is a link to what I'm currently looking at, so that just doesn't tell me anything. Where was it? Execution. Memory instructions. Yeah, there's a lot of like spurious detail in these. I suppose it's not. I suppose spurious is unfair because this is a specification, but like irrelevant to me detail is what I mean. Yeah. Let SZ be the length of mem.data divided by the page size. So yeah, this is in units of page sizes. So if you say memory and then there's an optional ID and then you say data and then you have a data string, that is equivalent to, so this is some sort of syntactic sugar. Right. So there's these two situations we saw in here, one of which has got this like inline data and another of which has got memory and then data that comes after it. The former is just sort of syntactic sugar for the latter. This triple equals here is saying like this is essentially equivalent or an abbreviation for this longer thing. So this is assuming that M is the number of pages. What's N? Oh, N is how many bytes the data string is. What's a data string? The data is written as a string, which may be split up into a possibly empty sequence of individual string literals. In the current version of WebAssembly, the only valid memory index is 0, or a symbolic memory identifier resolving to the same value. Not sure what that means. Like, you're allowed to provide an index, but it has to be 0. Okay. How do I find out more about this mysterious data string? I suppose I just have to take it at face value that that is just a string. But I'm not really sure. Oh, I was going to say I'm not really sure what that means. Strings denote sequences of bytes. They're enclosed in quotation marks and may contain any character other than ASCII control characters. Yeah, this is what I was wondering about, was encoding. Each character in a string literal represents the byte sequence corresponding to its UTF-8 Unicode encoding. Apart from hexadecimal escape sequences that represent raw bytes. Right, so at some point, I'm going to have to decode these strings. What does \a mean, though? Does it mean... Oh, this is a... Is that... Yeah, A, B, C, D with \A7 in the middle. Okay. Blimey. Okay. Okay, this is a lot of... I mean, I'm literally reading this for the first time. Maybe I should have read this in preparation for today's session. It's quite a lot to take in. Okay, so there's some kind of notion of memory segments. They can be sort of pre-initialized with data. I'm not really understanding how this data gets associated with this memory. Data segment. So maybe what this is saying is data segments allow for an optional memory index to identify the memory to initialize. So is that this? Memuse? Oh, of course that link doesn't go anywhere. I'm not sure how to interpret all this. I think maybe I'm just going to have to muddle through based on what I see here. And I guess the assumption... Well, but the problem is I don't understand what this means. Data I32 const 20. What does that mean? Data... This is such a horrible hypertext document, honestly. So, I mean, yeah, this is explaining an abbreviation, but I need to know what the data thing does. Data segments, maybe that's it. Oh dear. I'm really sweating on this one. I need to take the lid off this water bottle. Stuff is getting serious. Okay. Data segments allow for an optional memory index to identify the memory to initialize. Okay, well, I can't... But that is what this is doing, isn't it? There's a 0 and then there's a 20. So is that the... This says ID question mark. I assume that's the optional memory index. You think YouTube chat doesn't what? Oh no. What's happening? Data ID data string, data ID mem use, offset data string. All right, I'm pretty sure that what we're looking at here, I mean, maybe, I'm sort of jumping ahead, but I feel like I want to get a decent understanding. I think I know what to do here, but I don't know what to do here. Data i32 const 0, data i32 const 20. Okay, so what do the 0 and 20 mean? I'm just baffled by this. The only valid memory index is 0. But this isn't 0, this is 20. So why is that okay? What's a memory identifier? Oh, that has to begin with $. Okay, well that's... So this is init b star mode passive, mode active. The initial contents of a memory are 0 bytes. Data segments can be used to initialize a range of memory from a static vector of bytes. Oh, I mean, this is a nightmare, isn't it? Hold on. Am I just reading this wrong? Oh, it doesn't let you post links. Okay, if you search for WebAssembly runtime structure, there's a page in the spec about memory, page size, and data segments. Okay, thanks, Chris. WebAssembly runtime structure. Maybe this? This probably isn't it. We've looked at that before. I'm sorry, Chris. I don't know exactly where to look, but maybe I'm already looking at the right thing. Okay. Well, I'm a bit lost. It feels like we're going to need to do some of this string decoding. Turns out string literals have got a special syntax, so I hadn't fully appreciated that. I just don't understand what this spec is trying to say. Is Is this what it's talking about? But like, what is this ID? Like, where's the part of the specification that explains the semantics of this? Like, this is just syntax. This is very frustrating. I just don't know what to do with that. I just don't know what this 20 means. I mean, it could be like a byte offset in that memory. I just don't know. Like this is talking about, maybe this is a red herring, because this talks about an optional memory index to identify the memory to initialize, and maybe that's what this memuse is, because this has got mem idx inside it, so maybe it's talking about this other form that we're not seeing, and actually this is the one that I'm interested in. Data, and then an optional ID, and then where was that thing about the thing about the abbreviation? Module memories. And then, yeah, this abbreviation. Memory definitions combined a symbolic memory identifier. I mean, maybe that's not an identifier. Maybe it's something else. ID. Because, yeah, that needs to be $1. So maybe that's not there. Is it mem type? Oh no, I'm looking at a different thing. This mem type, I think, is the limits. Right, so I think it's fair to say that these numbers are either the minimum size of the memory in pages or the minimum and maximum size of the memory in pages. So I can at least make a little bit of progress here. These are unlikely to be the identifiers that I want to use, but this is at least me documenting my understanding. So I feel like I've understood what that syntax means. I'm still very unclear what this I32 const 0 is doing. It looks like there can actually be multiple strings as part of a data string that will just get concatenated together. Oh, is this it? Is this it? I was ignoring this because I thought it was this, but this, as an abbreviation, a single instruction may occur in place of the offset of an active data segment. So this thing here that is supposed to be an explicit offset can actually just be a single instruction. Right, well, we're not going down that rabbit hole, but I think it must be this. It must be this. It must be that this is the offset, but it's just using this abbreviation for the offset syntax. Oh dear. Okay. Right. So if your offset is a single instruction, which in this case it is a single instruction. Right. Okay. Okay. All right. All right. So I know I'm sort of getting ahead of myself a little bit, but we're going to need this data. For now, let's just say this is offset instruction. And then this is data string. Well, let's just call it string. That's fine. Okay, so that's what we're going to need. Offset instruction is e.g. And then again, what is the semantics of this? Like, I can sort of guess what it is, which is that this data thing puts that data string at that offset in the memory. Execution. Let's look inside modules. Don't care about typing at the moment. Allocation. New instances of functions, tables, memories, and globals are allocated in a store S as defined by the following auxiliary functions. Functions, we've already got tables, memories, contains n pages of zeroed bytes. I feel like something I'm not understanding here is what's the relationship between the data segments and the memory? Like, are they one and the same? Like, this has got separately, like, memories. You can put some memory definitions in. And then it says a data segment can be given in line with a memory definition, in which case its offset is 0 and the limits of the memory type are inferred from the length of the data. But does that mean that data segments so a module consists of types, functions, tables, memories, datas. So it seems like they are separate. Data segments. The initial contents of a memory are 0 bytes. Data segments can be used to initialize a range of memory from a static vector of bytes. So is the idea here that the data segment is the static thing that appears in the program? So this here is a data segment. This is a data segment. But what they do is initialize this memory with this chunk of data. Data segments have a mode that identifies them as either passive or active. A passive data segment's contents can be copied into a memory using the memory init instruction. An active data segment copies its contents into a memory during instantiation as specified by a memory index and a constant expression defining an offset into that memory. Okay, fine. All right, I'm actually getting somewhere. So the data segments are separate. If you declare them as passive, they just sit there being presumably like read-only data, or that you can use the memory init instruction to sort of dynamically stick them anywhere in the memory. But an active data segment gets copied into the memory when the module is, whatever the verb was, instantiated. Okay. All right. I'm very slowly getting somewhere with this. I mean, I think my understanding is still extremely weak, but that does make sense. So in the text format that was explaining these data segments, did it say that they were right? So this one, the one that's got an offset, is active. So this one, this is an active data segment, i.e. copied into memory. So at some point, we're going to need to also support the passive ones. But in this example, I think what that previous thing was saying as specified by a memory index and a constant expression defining an offset into that memory. Right, so the memory index is the thing that can only be 0. So I suppose these active segments can only copy themselves into the 0th memory segment in a module. That's what I'm guessing. Okay, so where does this get me? Flipping nowhere at the moment. So I think that when we initialize one of these memories, it's initially full of zeros, and the size of it must be initialized to be this many pages large, and then it can grow to, this is the maximum size. So we're going to need to have, in the same way as we've got some functions, we're going to need to have some memories. And I suppose I'm going to need, in the same way as I've got parameter and function, I'm going to need to have a memory. I don't know what it's going to have in it. I guess it's going to have some data in it. Bytes. Size. So does mem size change over time? Can we just compute that based on how many bytes there are in the... Let's see. Memory instructions. MathJax. Wow, it really kills my stream encoding when this page loads. I wonder if it's any better in Safari. I don't know. So memory size would be the length of mem divided by the page size. And then this allows you to grow the length of the memory. Records its type and holds a vector of bytes. The length of the vector always is a multiple of the WebAssembly page size. Right. Okay. So it can be grown. So let's just say that okay. What am I trying to do? So I need to be able to support this this. So this memory data X. Oh, why did I close those tabs? Well, it's because I'm worried about MathJax and its memory and CPU usage. So the limits of the memory type are inferred from the length of the data rounded up to page size. So yeah, in this abbreviation, this M is the M is inferred, the minimum and maximum size of the segment is inferred from how many pages does the data string take. So here, yeah, the abbreviation is literally data string. Oops. And so here we need to make a new memory, and its bytes are how do you make an array filled with zeros? This is the kind of Ruby that I almost never do. Like, how do we make a big empty array? Like this? Array.new. Oh yeah, Leo is suggesting I could just do this. The documentation suggests that there's a constructor where I can say, give me 123 zeros, please. Yeah, I think this is slightly nicer. Do I want this to even be an array, or do I want it to be a string? Because really, a string is the best approximation that Ruby has to like a buffer of bytes, right? I'm going to make it an array initially, because it feels like that's going to be less painful. I just don't really want to get back into flipping pack. So okay. So what's the size of this memory going to be? It's going to be, we sort of want the ceiling in pages. So essentially it's like string dot, how do you get the length of a string in bytes? Do I just have to do string.bytes.length? Yeah, returns the count of characters, not bytes. Oh, byte size. Okay, great. So that like mod the page size. Yes, thank you. You are correct, Leo. But unfortunately, the lag means that your information is reaching me too late, my friend. Oh dear. This is the most stressful. This is 10 times more stressful than the than all of the other streams I've done. Because up until now, it's just been like hacking away, implementing floats and integer operations and S-expression parsers. But now I'm like, oh no, I'm having to learn something about how WebAssembly works. They never told me that this day would come, that I was actually going to have to write a WebAssembly interpreter. That was not, I was not told about that. So that's very upsetting, but never mind. So that's going to give us 1 too few. So we're going to have to add 1 to that. I mean, no, that's not right, because it could be an exact... What's the operation I want here? Why can't I get my head around simple arithmetic? Okay, if I subtract 1 from the byte size, so let's imagine that page size is 100. What I want is, if I've got, if my byte size is 99, then I should be able to say byte size minus 1 divided by page size. Gives me 0. Then when we add 1 to that, we get 1. And then, why does that happen? And then we multiply it back up by the page size. Now the question is, so firstly, if byte size is 0, maybe that's okay. If byte size is 1, that's okay. If byte size is 100, this was the edge case that I was worried about, that's okay. And if it's 101, well, I didn't actually try it with 100, did I? But that is okay. 101, 200, 199, 200, 200, 201, 300. Is that right? I think that's right. Well, except this size only needs to be in, well, no, it doesn't. Let's do it in pages. Size in pages is byte size minus 1. I don't know why I was doing mod. This is me not thinking. It's division, not remainder. That was just completely, that came from nowhere at all. That was just a random noise in my brain. So we have to subtract 1 from the byte size, and then we divide by the page size, because we're going to add that 1 back on, I think. So we're sort of correcting for, if it's 100, that fits in 1 page. If it's 101, that fits in 2 pages. If it's 200, that still fits in 2 pages. If it's 201, that fits in 3 pages. Okay. Basic maths conquered. All right. So the byte size of the string, we know now how many pages this is going to be. And so now we need this to be, well, Leo, I think if the string is empty, then the answer is 0. I'm not entirely sure, but we do have an example of that. So this one that doesn't even have a string, the memory size is 0. And this one that's got the empty string is also 0. This one that's got a string with a single character, it's one page. So, and I suppose what you're asking, what happens to this expression in that case? Let's see. Byte size is 0. We get 0 because of the miracle of division. So yeah, the fact that that subtraction and addition sort of cancels out means that we're okay for the empty string. I hope, he says confidently, but I'm hoping that that just comes out in the wash of the maths. So this needs to be, few indeed, multiplied back up by page size. Obviously that's a little bit wasteful of memory, but I don't know how much I've got. I've got enough. Ruby is all of our passion, Leo. Okay. And I suppose this version where there is no string is kind of the same deal. It's sort of an annoying thing about pattern matching in Ruby is that I don't know a good way. Maybe in this case I do know a good way to match this with or without the string. Anyway, where the hell are we? I haven't run the test in a really long time. I've just been... Oh. Come on, Ruby 3.2. Why is it not Christmas already? Okay, so still expected 1 got 0. How is this one working? Oh, it's because... I guess it's matching this one. But it shouldn't. There should be a separate one for just data with no. So I guess here I'm just going to say memory new bytes empty. Okay. Well, I mean, that from the outside that looks exactly the same. But now we might be in a position to actually implement that size operation correctly, because, well, except these memories aren't available inside the interpreter unless I thread them through. Oh dear. I mean, obviously I could just set an instance variable with the memories in it. I don't have any real representation of a module, I guess, is the problem. Oh, how am I going to deal with this? You know, what I need to do is in memory.size, I need to be able to ask, like, you know, memory equals get it somehow, and then return memory dot bytes divided by page size. But do I really want to pass memory through like this? Or memories, I suppose, is what I would be passing through. For now, the answer is no. So does memory.size like, how do we know what memory we're talking about? Is it that you can't have more than one? Like, is that the point here, that this is invalid, that there's only one memory per module? Maybe. doesn't obviously say that here. It all talks about memories. Yeah, I can't see anything particularly instructive about whether we can have more than one memory, but this actually, what I'm seeing in this test makes it look like you can only have one per module. So actually, this thing about memories, even though that word appears all over the place, might not be... Okay, look, screw it. What I'm going to do is just make an instance variable for now. And then here, I'm going to assign it. So that is just a very lazy way for me to smuggle that value down to here. So that's how many bytes we have. This is the same thing again. Yes. So if there are 0 bytes, it's going to be -1 plus 1. If there's 1 byte, it's going to be 0 plus 1. Yeah. Oh, well, that didn't work. Expected 1 got 0. So what have I forgotten to do? I don't understand what's going on here. Why is this? Why is the array completely empty? I don't know what this sequence of emojis means, Leo. If you've got some helpful advice, I would... What? Have I got these the wrong way around? Yes. I didn't see you say anything about this, Leo. I don't know if it's just not showing all of the things you said. I didn't see you say anything about the order of these arguments, but I will believe you. Okay. What you said after few is Ruby is my passion. So if there was anything between few and Ruby is my passion, that has not made its way through the series of tubes. Okay, so I've still got some kind of problem, but at least now it's a different problem. Yeah, they seem to filter all kinds of stuff out of the chat. You know, Zeta was saying that he couldn't post any links either, so I don't know. When people join the chat and spam links to adult dating or spam adult dating site information, it seems to get through absolutely fine, but, you know, useful information that would help me, not so much. Oh yeah, probably. It's probably that array.new looks like a URL. Expected 0. Got 1. Okay, so this is actually an earlier test that's failing. So this isn't super helpful. Although I can see the assertion that's failing, I don't know whether it's this one or this one. Well, I do know that it's this one because there was a green dot there. Why is that happening? Oh, crap. It's because... It's because this isn't the empty string. This is the symbol from the S expression that's 2 characters long. Yes. I'd forgotten about that. So when we parse the S expression, string literals are not treated... Well, they're parsed differently, but we don't strip off the quotes from around them. So I'm going to have to do that manually here. String... What? Delete prefix? Delete suffix? I don't know if... Is there any better way of... Oh, I don't know why I'm looking at that. That's useless. Is there a nicer way of removing quotes? I don't think strip or chomp or any of those things are particularly useful. I suppose I could use strip. Oh, it's only white space. Squeeze. No. Okay, well, if anyone for whom Ruby is their passion knows a cute way of removing the quotes from around the string, then please tell me, but I'm just gonna use that naff way for now. Okay, look, we've got further. So that's good. The fact that I'd forgotten that the strings include the surrounding quotes is somewhat annoying, but we got there in the end. Does it make sense for me to be converting back and forth between bytes and page size like this? It's probably fine, isn't it? So loads of, well, I got 3 passing tests, then loads of pending tests. So those 3 assertions pass, and then there's all this guff about assert invalid. Like, the more time goes on, the more I think I should probably start trying to make these assert invalids work, but it's never felt like, well, I'm still trying to get flipping float expras.wast passing here. Like, I haven't felt like I've got to a point where I've achieved enough to be able to justify going back and spending 5 hours getting, you know, a mechanism for raising exceptions inside the interpreter. So all right, so assume we've passed all of those. This is complaining about func export result store blah, no matching pattern error. So what is this? Func export cast. Right, so somehow this was all fine. I don't know how. How did it deal with these data segments? Oh, because I've got a... Right. Okay. So that's okay. I haven't implemented them yet, but we haven't seen any assertions about it yet. But it's having trouble just even parsing this. Func export cast result F64. Oh, this has got a flipping conditional inside it. I didn't notice that before. I didn't notice that we were going to have to deal with this. Well, I was hoping that we weren't going to have to push any more of these tests onto the stack. I mean, maybe I don't need to. That's just one occurrence of something that I can probably... It's probably within my powers to figure out what if-then means. Let's just see. At the very least, let's have a look at the test for that. If then else. So it looks like this has got like a condition and then a consequent and then an alternative. What the heck? Oh, and it's got this sort of optional type annotation. There's an awful lot of this, isn't there? Like a lot of the syntax of this language has got loads of optional stuff. And unfortunately, pattern matching doesn't really support that very well. By which I mean at all. But okay. No real surprises there. I assume that this is going to be interpreting this as a Boolean. Why don't I just find out how it interprets it? Execution. Control instructions. Every time I open one of these pages with MathJax on it, I can see my stream health plummet. Oh dear. If pop the value i32 const from the stack. If C is non-zero, then execute the block instruction block instra 1. Otherwise, execute instra 2. Okay, well, I think I can just about deal with that. But is that why the pattern doesn't match? I was surprised to see more than that. Func export cast result I64. Is it because it's somehow got mysterious multiple bodies? Like, I think that might be it, actually. That up until now, all of the function definitions we've seen have just got a single expression as their body. But this one appears to have multiple expressions. So I suppose that's something that we have to support, and that these just get evaluated one after the other, I would imagine. Sorry. Function instances. A function instance is a runtime representation of a function. Effectively, it's a closure of the original function over the runtime module instance of its originating module. Okay, well that's... Oh, interesting. Thanks, Chris. So is that in here? Because I know this is why we started looking at memory in the first place. Or are you saying that there's a separate float memory? Ah, in here. Right. Float memory. Yes, you're right. This does look more manageable because it doesn't have any conditionals in it. Excellent. What else is there? It made me realize I didn't really survey what was available memory-wise. But yeah, that's a really good call. Maybe this is the one to be looking at. Okay, let's pop over to that then. I would much rather just get one of these things working, you know. So I think having one that has got fewer dependencies is great. Thank you. Okay, so what's this complaining about? Func export. Yeah, it's just going to be floats for the rest of time now. It's just me and my career as a floating point engineer. So what is this complaining about? F32 store, export F32 store. It's not happy. Is it because there's no result type? I'm just going to stash this. I think this will still be failing for the same reason. Oh, no, it's failing for a different reason. Okay, never mind. It has to get past the memory data bit there. I'm going to have to write a function that interprets these, aren't I? Like, it's not just removing the leading and trailing quotes. It needs to actually be fully interpreted. But I mean, this is this is sort of like, you know, this reminds me of like pack and unpack. This is pre-allocating the memory segment in this module, or pre-populating it with some data, then exporting these functions that are that close over that module so they have access to the memory segment, and then it's just invoking these functions to sort of read and write various values into the data, and it looks like it's interpreting them as floats and integers, essentially. Okay. What was I doing? I'm trying to understand why the pattern match is failing for this function, F32 store. Yes, it's because it's expecting there to be this result type. I wish I knew a way to just make that optional. I mean, because this doesn't have any... No, it doesn't work. The only thing I can think of is like that. Does that... Let me try it. Right. So if I made this a choice between something and nothing... No. That doesn't make sense, does it? So I don't think that's going to work. No, it's not even syntactically valid. Crap. I mean, I suppose this is some motivation for me to extract these bits and pieces. Because what I need is a copy of this that doesn't have this. I think. Actually, it needs to come afterwards because that parameter's splat is completely unconstrained and it would just eat the... In fact, the way I'm dealing with this... I think the way that I'm dealing with this entirely is sort of wrong. I think what I should be doing is just sort of iterating over everything that comes after func here, and depending on what it is, allow it to have a side effect, which in the case of result, with the result type, is nothing. In the case of body, that becomes the body of the function that we're currently generating. And in the case of export, that becomes the name of the function that we're currently generating. So I think my whole approach here is actually a bit wrong. So rather than make it worse, I'm going to try to clean it up. So let's say function equals function.new at the beginning. And then at the end, we return... Well, in fact, I can just do tap do function. And then some stuff is going to happen to the function side effect wise. And then that function is going to be returned at the end. So right now, to just keep this compatible with what I've already got in that pattern there, I can just do function.name is equal to name. This... Oh, actually, we don't just return the function, we add it to the list of functions, don't we? So that's what happens. So we have to set the name, we have to set the parameters, and we have to set the body. And at the moment, those are just being yanked right out of that expression. So I think if I... Right, that all looks okay, doesn't it? So hold on, I'm going to start. I think I need to do this. I'll just make that work in progress. I'm not sure whether it's worth committing this on its own. Yes, it is. So let's say create empty function during definition and mutate it to fill it in during definition. This more closely matches the way the language works. Each function definition is a sequence of mostly optional in some cases, multiple different kinds of data or information about that function, and it's hard to write all possible pattern matches to support them all. It'd be much better to just interpret the function definition one expression at a time, which I will begin doing in the next commit. But first, we need an empty function definition to mutate. Okay, so now we can do the mutation. So I think this can become a lot, this can just become like expressions in here. For now, I'll leave body at the end because I think here there is only one body for every function. Back in the memory.wast, there were multiple expressions for the body, but for here, I'm just interested in supporting this, not having a result type. So now inside here, I'm going to say, not parameters, this is expressions now. So I'm going to say expressions, each do expression. And then there's going to be a case. And when it is, when it's in export name, we're going to set the function name. When it's in, yes, when it's in param name, okay, right, we're not going to have that map anymore. This is going to be function.parameters. So this initial function needs to have, maybe this should be the default for the function class, but it needs an empty array of parameters that gets populated with these. And likewise here. And then now I've still got this function body on the end, sort of unnecessarily. I'll stick it up here for now. And I guess I want result blah, and this just does nothing for now. I wonder if I can see in the syntax what order these come in. Modules, functions. So these do kind of come in an order. In fact, it's easier to read the I think it's in the reference interpreter. It's got a sort of a more tractable version of the syntax, yeah. Func. Yeah, so it's like, does it have a name? Oh no, okay. It's not. This grammar is not as useful as I thought it was going to be. Import string, func name, func type. Okay, forget it. Forget it. I was only looking to see if there was a natural order for these things to go in. I think there's the export, and then param, and then result. So, and that's the order I've got them in. So that's fine. Okay, so does it still... Okay, so this appears to still be working. So this is all just taking a run up at what the thing I actually want to do. I'm confused about how this is working. Because I took out the function body. Oh, it's because of the... because of the... Yeah, okay, I didn't take it out. I put it in. Okay, I just missed it because it was... Because it was in shorthand syntax. Okay, not that. Just that. Okay. So I'll say iterate over expressions in function definition to set up function. I need this to support more stuff being optional, specifically the result type in this case. Okay, so now we should be able to go back to where we were and have a different error. All right. So we finally reached a point where I think all that what do we actually need here? I feel like this memory data is the thing that we need. This one. All of that was junk. The end wasn't junk. That was very important. But we didn't need all of that. I don't think we needed this. I mean, this is all because we switched to a different test, right? Yeah, okay. So we're hoping this is going to initialize it to, it's going to be to complete junk. But this does get initialized. And now we need this i32.load instruction. How on earth is that going to work? And what indeed does it do? So it takes one argument, which I assume is, you know, an address for it to... I mean, maybe these could go down in here. Yeah, I think it probably should, because it's got an argument that needs to be pre-evaluated, and that's what this whole section is about. An integer argument, that is. So this will just be load. Loading. Value. Let's just see if execution even makes it that far. Yes, loading 0. Okay. It was supposed to return something other than Ruby false. Okay. So what does this actually do? I assume what it's going to do is load 32 bits starting at offset 0. I choose to believe that that is what this does. And the answer it's looking for is 7F A00000. Now it looks like this is stored least significant byte first. So is there anything about endianness in the spec? Does it say that this is all little endian? Execution, memory instructions, watching to see if my stream goes wonky. Indeed it does. So load byte sequence, for which bytes yes. When a number is stored into memory, it's converted into a sequence of bytes in little endian byte order. Okay, I understand that. So we just have to deal with it. Could use could use our old friends Pack and Unpack for this. Maybe that is a reason to store it store it as a string. Oh, boo. Okay. So there are several problems here. One of them is that I'm not interpreting these backslashes. So this is not being stored as 4 bytes. It's being stored as, 12 bytes? And the wrong ones at that. And the second problem is I've got to figure out a nice way to load a little endian string, a little endian sequence of bytes into a 32-bit integer. I mean, obviously I could do that myself by just shifting and ORing, but it is making me reconsider my decision to store the memory as an array. Because maybe it does make more sense to just store it as a string. I'll do it myself just to get the test passing, but then I think maybe I will go back and change that decision because we haven't even used it yet and it already feels like it was the wrong decision to store this as an array, because clearly we're going to need to be treating this as just just like a soup of bytes that we need to be interpreting in different ways. And in Ruby, the built-in type that supports that operation is, unfortunately, a string. So, and then I'm just going to have to be really... The reason I didn't want to use a string is because it feels like it's just inviting me to constantly forget that characters are not the same as bytes. And if I store them in an array and it's an array of bytes, then I never need to worry about accidentally accessing it in some way other than by byte offset and by, with a range of bytes. But I'll just have, if I use strings, I'll just have to be on the ball and make sure I don't get confused. All right, so I think the next thing I need why don't I try and implement this, and then it's going to fail because the memory has been populated incorrectly. So bytes is memory dot bytes dot slice value 4. Is that how array slice works, or indeed any slice? Can you give it a length? Oh, start and length. Yes. So if I've got, you know, 0 up to 10, and I slice that, and I start at 4, and I ask for 5, then I should get 4, 5, 6, 7, 8. Yes. Okay, cool. So that gives me the bytes I want, and then the result is I'm just going to do this in the stupidest way possible. Bytes 3 shifted left. Don't get it wrong. Is it 24? And then bytes 2 shifted left 16, and then bytes 1 shifted left 8, and then bytes 0. I think that is the answer. I think that's the implementation of that instruction. I mean, I wasn't expecting it to be all zeros. Oh yeah, I was, because I haven't implemented this. It doesn't do anything. Okay, so that's what I want, is to see junk in there because the string is not being interpreted properly. So yeah, indeed, this just allocates an empty memory. I mean, why don't I just make it a string now? Because it's not like I've used this at all. How do you make a string initialized to a certain length? Is that a thing? Methods for creating a string. New. Well, that's very inventive. Capacity, what does that do? Oh, so that's just internals. Okay, well, none of that's very helpful, is it? I might have to do the Kasarani maneuver here and say that my string is, 0 byte times Yeah, I think I am going to have to do that. Oh well, sorry Ruby. Is there any better way of doing that? No, I suppose not. I don't know a better way of doing that. So let's say bytes equals 0 times size in pages times page size. And then this, oh, I've already done this. I'll just inline this. Okay. So now this memory.bytes is just going to be a string. So I need to rethink. Well, I suppose I don't need to so much rethink as re-implement the load instruction, because now this is it's just going to be an unpack, right? So memory.bytes dot unpack one. Well, it depends on what the value of bits is. Raise unless bits. Oh, I thought I'd got away from pack and unpack, but it feels like it would be dishonest to not use them here. There's really no... Just because I don't like them, it would be silly for me to re-implement them just because I find them a little bit distasteful. Like, just because the API isn't great, I can hide the API behind some more pleasant helpers, but this is just gonna... I'm just gonna be stuck with this. So I think that's L. Yes, 32-bit. Oh, but that's... Right, when I was using these before, I was playing fast and loose with endianness, because as long as you pack and unpack with the same endianness, it doesn't matter what it is, because you don't even look at the intermediate, the contents of the string. But now I do care. How do I get these little endian? I have to put a less than. Although I can just use a V. V for Vax. In fact, I'm pretty sure that native order is little endian anyway, but obviously it's better to be explicit about it. I think I would rather use the thing that I already know, the L, but with a less than to mean little endian. So let's check and see whether that works. So here's our string. I wish to unpack one that with, is that what it was? L less than? And what is that as hex? Oh, what is wrong with me? That's not right. (7FA). Oh, it's because this isn't legit, is it? How do you do this in Ruby? Is it like \x? Yes. Yes, that is correct. So yes. All right. Great. And then just out of, well, I know what it looks like. It looks like this. Right. I don't fully understand why this one has this thing got, oh, this thing doesn't have an encoding, does it? It has like, yeah, okay. Yeah. Yeah, I was confused about why these weren't showing up as these Unicode escapes, and it's, yeah, because when I write the string, I'm writing a UTF-8 string, but what you get back from pack has got this misleadingly named ASCII 8-bit encoding, which means essentially it doesn't have, it's just raw data which is ultimately what we want. I don't think I need to worry about that though. Anyway, this is correct. So I have to make it little endian. So now what happens when I run that test? Still getting 0. Oh, that's because I still haven't even tried to put the string into it. Still the same situation I was in before. Yes, okay, so let's say, let's not inline it. Let's do this. And then this gives me the opportunity to splat my string into it. How does that work? Again, not the kind of programming I usually do in Ruby, but modifying a string, insert at a given offset. You can set the byte at a given offset. So is there no like... Because I sort of want to slice out part of the string. Is there like a... Yeah, I really don't know how this works. Oh, here we go. Okay, yes. So you can do slicing. It's just that it didn't say that in the... Okay, great work, everyone. Oh, in fact, I don't think this is alias to slice, is it? I just have to use square brackets. Square brackets equals string. So what I want to do here is say, so at integer, new string, replaces sum or all. The portion of the string affected is determined by using the same criteria. The string will be adjusted accordingly. So is the second integer the length? Right, okay. So rather than try and understand that obtuse documentation, hello world. So if I say slice 0 equals goodbye, string 0. Right, the H has been replaced by goodbye. So if I want to splat goodbye into that at the beginning of that string, then I have to say like goodbye dot length, and then it's equal to goodbye. And now, yes. Okay. I think I don't have to worry about bytes at this point because I've arranged for this string. It's going to be the right number of bytes, right? And even though I believe these are all character-wise rather than byte-wise, that should be okay as long as we're on character boundaries. I don't think there's a version of this that lets you operate on byte offsets. Oh, that is problematic, isn't it? Because I'm sure that this is in bytes. So how am I going to get a substring? Oh, is making me regret my decision. How do I find byte offsets in a string object? Oh, there is a byte slice. Returns a substring of self, or nil if the substring cannot be constructed. So what's bytey about it? Just doesn't say. Returns the substring beginning at the given index of the given length. Well, this documentation doesn't say anything about what that means. How can I use regular expressions, Chris? I'm not sure how that would work. So if I've got some string, oh, okay, fine. Okay, so it looks like, although the documentation doesn't say this, it looks like these are byte offsets, because here I've got a multi-byte character in my string, or a two-byte character actually. This byte slice is starting 4 characters in, which is 5 bytes in. So that allows me to read. That's fine. So this needs to be byte slice value 4 bytes. I don't think I really need to slice out the specific because I think unpack will just ignore anything beyond what it was asked for. Oh, unpack lets you specify an offset. The keyword offset can be given to start the decoding after skipping the specified amount of bytes. Okay, that's great. So I don't need to use byte slice here. I can just say offset value, because that is what that is. So that's good news. It's just bad news about writing. Well, for this it's fine because it's at the offset of 0. What I'm worried about. Sorry, I haven't really articulated this, so it's not surprised that it's not clear what I'm trying to do. What I'm worried about is how do I overwrite part of a string at a specific byte offset. And I don't think that there is a way, or at least not I can't see a built-in way of doing that. Which is worrying. I mean, it's not the end of the world because you can always round trip through the array of bytes. So I can always just make an array of bytes, and then I'm actually not sure how you go the other way. Like if you've got an array of bytes and you want to turn them into a string, how do you do that? Because join doesn't seem like the right operation. Anyway. Oh. maybe I'll have to change my mind and go back again. Maybe what I'll have to do is store it as an array so that I can access the byte offsets, and then when I want to read and write from it, I can go through. I can use a temporary string as like to get the bytes in and out of that array. Anyway, I don't think that's a problem right now because this only needs to write at offset 0. So please, can we see something other than yes? All right, expected that, got that. So if I pack that, these are all ASCII characters. So it's a backslash, a 0, and then a backslash, which isn't quite what I was expecting. Hold on. Oh no, that does work. That's that. Okay. Right. So that is actually working, or at least part of it is working. It's failed successfully. But now what we've got to do is interpret this string. And part of that is going to be stripping the quotes from around it. So I've sort of been putting off having to do this for a long time, but now's the moment. I feel like I'm in a right mess here with all the crap I've put in here. Maybe it's not so bad. It's just a few comments. So let's do something like parse string. Because that's going to have to, well, first it's going to have to do this. And then we're going to have to look for any of these special escape sequences. Once upon a time, I had the page open for this, but it was too much stress on my CPU to handle. This is what I need. Well, for this specifically, it's just this bit that I need. Anywhere that's backslash followed by 2 hex digits, which doesn't overlap with this, because none of these are valid hex digits. So there's almost been a bit of design involved here. So I just need to make it. Okay, how's this going to work? What's some ASCII characters that we know? It's question mark A. What's the method that tells you? Doesn't matter. Anyway, 65 is capital A. So what I should be able to do is take a string that's got backslash 41 in it. So here, if I G sub literal backslash followed by 2 hex digits, and this is a capture group. I think with gsub you can give it a block, he says, hopefully. You get a block with a with match data. In the block form, the current match string is passed to the block. Special match variables are set appropriately. Okay. I mean, that is just a... I mean, let's just say it's not very good. In that case, what I want to do is make the match itself just be the 2 digits. And I want this to be a 0 width backwards assertion. Look behind. I thought it was in Vim for a second there. That was exciting. Right. So if we've got a 0 width look behind assertion that's saying before this we want a backslash and then we want 2 hex digits. So now I've got those 2 hex digits and I want to do, so this is digits to integer base 16. Oh no, I do actually need the... Sorry, and all of that gymnastics was unnecessary, wasn't it? Okay, that's what I'm looking for. Or maybe I can delete prefix is better. Okay. I mean, why you don't get a match data here? This is fine. So we delete the backslash and then we need to turn this number into a character. How do you do that? To C? Oh no, that's complex. There must be a method on integer that gives you a string. I just don't know what it's called. Chur? Returns a 1-character string containing the character represented by the value of self according to the given encoding. I'm just thinking about the encoding aspect of this. I think... God. Right, so that does work. So if I take this string, I think I still have to escape the backslashes in here. Yes, okay, what's the encoding of that string? Okay, ASCII 8-bit. And the encoding of the original string will be UTF-8, I think. So is there any problem with me saying encoding UTF-8 here? The answer is yes. I'm not sure how worried to be about encodings here, because I think the resulting string is fine, and maybe I would just have to force its encoding back to UTF-8. Yeah. Yeah, I think that's probably okay. I'm just going to roll with that, because like, does the right thing happen if we set the top bit here and it's just like FF? Yeah, I mean that's what we want. We want it to be, encoding ASCII 8-bit is kind of the right encoding. It's just that the strings that appear in source are UTF-8 strings, and so we need to be sensitive to sorry, I don't mean to obsess over this, I just want to try and get it right. This IRB is not good, is it? That's not what I wanted. I wanted to do this. Cafe says that. Right, incompatible character encodings. So I think maybe what I need to do to make this work is to force the encoding of this to be encoding. So that turns it into a sort of undifferentiated soup of bytes. But is there a way? No, I think that's safe. I can't think of a way that is going to cause problems with this process, he says, hubristically. Oh. So now I've done my substitution on it, and then if I force the encoding back to UTF-8, what I'm hoping is that I'm going to recover my original UTF-8 string, but with those sort of byte-wise substitutions inserted into it. Yes. So I don't know whether this is strictly the right thing to do. It feels like a pretty blunt instrument, but it's what I'm going to do. So tough shit. I can always come back and refine this if it needs to be something more clever. Let's do this in pieces. Oh, I guess force encoding. Yeah, that mutates the original string, doesn't it? So here, we force its encoding. I mean, this all just needs to be like this then. So, I mean, I could duplicate the string, but I think I should. I think I should do this. And then this can all mutate it. Otherwise, I'm setting myself up for pain with the string that's being passed in here. It's notionally part of the abstract syntax tree, so the idea of going in and fiddling about with its bytes gives me the willies. So this is going to give me a copy of that string, and then I can force its encoding. And then does it force encoding just returns the string, right? So I can force encoding, do the G sub, and then force the encoding back. So does this work? Who knows? I haven't run this code in what feels like hours. Undefined method string for string. Right. Did that first test just pass? I think it did. This passed. Okay. Oh, wow, okay. All right. Come on. We can do this. Together we can do this. Okay, well, amazingly, that seems to be doing the trick. I wonder whether that encoding thing really matters. I don't know, but that represents my best understanding, so it'll have to do for now. So the reason it failed is because we don't have F32 load. So let's have that. Again, needs to be 32 bits. This time it's a double. Less than only allowed after those specific types. Okay. Why is that then? Oh. Okay. We have to use a special different letter for these, in which case I might as well use a special different letter for these, because otherwise there's no point, is there? I was hoping there was going to be some symmetry here, but basically I just need to use V. Where's 64-bit unsigned? Where's 64-bit unsigned little endian? There isn't one. You have to use Q less than. But there is no less than for these. Ruby, go home. Okay, fine. So it needs to be it's a little e. Look at the state of this. It's capital D or lowercase d means double precision. big F and little f mean single precision, but the format is unknown, or at least it's not portably consistent. But then big E and little e mean double and single precision. Oh, okay, fine. All right. Let's not think about that. I mean, imagine how terrible it would have been if they'd made it D less than, because then you would be able to use what you learned about these integer format strings, and that knowledge would still work for floats, but right. You're correct. That's not what I was supposed to do. Because of course that was just a test. Because as anyone knows, we are not going to unpack a float. We are going to unpack an integer. And then that's it. Because that's how we represent floats, is as integers. I could go through the rigmarole of turning it into a Wasmina float using decode, and then I could encode it at the appropriate format. But if there aren't any bugs in my code, that will just produce the same number again. So I can just do this. Oh, yes. Okay. 2 tests passing. Okay, well, I'm well overdue a commit, aren't I? Hours ago, I should have done a commit. It's just that until now, I had no sense of whether it was actually working or not. So I think I'm going to begin with the parse string helper, because I need that to populate the memory segment. Why does this say I've removed the functions line? Did I not commit that as part of my previous change? Right, well, that was very silly. Right. Okay, that makes more sense. Okay. So this is implement interpreter parse string to interpret WebAssembly string syntax. I think I've got a citation for this. Wait for the stream to half conk out as I try to... Okay, I think this is the best reference I have. Strings are UTF-8 and contain, among other as yet unhandled escapes, / escaped hex, 2-digit hex characters representing specific bytes. To unescape these, we convert the string to ASCII 8-bit encoding, then replace all the backslash sequences with their equivalent bytes, then convert back to UTF-8 so the untouched parts of the string can still be interpreted correctly. So it's not a fantastic link, but it does link to a document that explains that. I should also mention strings are also the raw, so like unparsed strings are also the raw atoms from the S expression, so they still have the surrounding quotes, which we must remove ourselves. Okay. I'm just trying to think, at some point I should put the fact that we're trying to get float memory working should be pushed onto the end of our... Do you think I should just... Should I just drop this memory? Like, if the thing that I'm trying to do is get float expras working, does this depend upon anything memory related beyond what we've already seen? Oh look, this can be a sequence of strings like. So this looks very simple. Load. I think maybe what I'm going to do is replace this with float memory and say this is the... Instead of going 2 levels down the rabbit hole, I think we're just going to go 1 level down the rabbit hole and say... I don't know why I can't type interpreter. So I think I'm actually gonna I'm gonna change my mind about this. So actually I need to change this because it mentions okay, so I'm just going to do a run of the test to make sure that nothing else has got broken and everything that I'm expecting to work is working. Just talk amongst yourselves while the tests run. Okay. All right, so everything's still working the same that it was. Okay. Right, we don't even have that kind of expression in this file, I don't think. It's all just memory data. We don't have that one that's got the range of integers. So this is, yeah, thank you, Chris, for finding this, because I think this is, I just completely overlooked this before, but this is obviously going to be easier to conquer than the full-blown memory thing. So what's in my diff now? Page size, memory struct. I mean, that memory struct is really not adding anything. It's just, all it is a string. But I might as well just leave it there for now. So really the only useful thing there is that we implement the, I mean, look, if I stash these changes and we run the float memory test, oh. What? That's not good. What have I done? There's something gone wrong with my, yeah, an end has gone missing. Well, that was a very unclean bit of Git rebasing, and I apologize for that. Okay. So I think it belongs. Well, actually, I don't know where it belongs. Where did that mistake happen? Yes, I think where I removed that functions, it should have had the end put into it. That is fine. It's this one that's the problem. Okay, so now, okay. So what have I got here? Yeah, sorry, that's what I was doing in the first place, was trying to see how the test fails. Memory, data, no matching pattern error. So the next, in this fiction we're telling, it's this bit that gets added next. Minus all of the junk. So I think that's the minimum. Just pausing to think whether maybe that page size constant should live inside the memory namespace. Maybe that would be slightly less grim. I'll come back and change that once because I'm in the middle of a thing here. Right. So let's say this is implement memory with initial data segment. Let's, while I remember that it exists, let's find that bit of the spec. It was memories, abbreviations, this syntax is an abbreviation for a memory followed by a dynamic data segment. That's not the right word for it. I don't know why I've said that. I just invented that. Maybe it's in structure. Data segments. Active. Okay. Followed by an active data segment whose contents get automatically copied into the memory when the module is, what was the right verb again? Instantiated. Okay, that makes sense. We are missing some kind of context object. Current frame, current module, current something else. So there's nowhere obvious to keep the current module's memory. And I don't want to laboriously thread another argument through all the recursive calls of evaluate. So I've just bunged it into an instance variable for now. Rest assured, this is not my long-term strategy. I'm just trying to get the tests to pass shamelessly. Okay. Okay, so what's the diff? A crap load of comments. I hope that when I run the test it complains about i32 load, yes. So that's what I'll do next. Oh, maybe I should have... I didn't say anything about why the memory was being represented as a string. Oh well. Too late for that. Onward. So this is... my old friend, this commit message. now, hopefully. F32.load. Okay. So now all I've got left is messy comments, which I'm going to stash. I think that's the only stash that I've got. Oh, well, that's not true. Okay, well, it's a recent one. So I'll just try to remember that I've got, as I work on this memory stuff, I've got some, ironically, some things I need to remember in my stash, but I don't really want those comments in my, actually in the code, because they're very messy. And not so much messy, but distracting. And I need all of the focus I can muster at the moment. Okay, so let's see. I don't know if this is realistic, but let's see how far through this we can get. It looks like reset just, well, I mean, basically we need to implement store, and then maybe there's a chance that this file will just pass. And if so, that's, you know, that's good enough for me for a Wednesday's work. Right. Invoke reset. No matching pattern error. So that surprises me. Why can't it just invoke? Oh, it's because there's no, it's not an assertion, it's just an invocation. Okay, that's curious. So we're invoking this, I guess now for the first time, we've actually got some mutable state here inside the module. And so it makes sense that the test script would want to be able to actually change, to do something that's not an assertion, right? To be able to actually just run one of these functions and not care about its return value. I was going to put this at the bottom, but then I think maybe having all of the assertions together at the end, because they are notionally the last thing that happens, is like define a load of modules with some functions inside, blah blah blah, and then do some asserting. So I think the idea of keeping invoke, even though this is really just as good as an assertion, keeping it up here is a good idea. Let's do it with arbitrary arguments. I clearly need to, there's clearly a function I need to, a helper I need to extract here, because this is massive. Well, where's the function call bit? I'm just going to copy it for now. I'm going to make this an error. Because if the test, it's one thing when, well, no, I'll leave it a warning. That's fine. So here's the bit where we actually call the function by combining the parameter names with the argument values, which will work fine in this case because it's just an empty list. And then I just actually don't care about the value. And yeah, I mean, I've just... Oh, right, okay, so now it is actually trying to evaluate reset. Store 0, 0. Right. Why is it 0? That's not right. Should be a 1. That's concerning, but that's not specifically the thing I'm trying to do right now. So this is actually a command. So this is implement invoke command outside of any assertion. for the first time, we're running a test script, i.e. float memory.wast, that wants to be able to invoke a function for its side effects, not its return value. So we need to be able to support that. I've copied and pasted a big chunk of code here, so a method needs extracting fairly soon. I just want to make the test pass first. Invoke reset, evaluate store 0, 0. Why the heck is that getting 0 and 0? I'm extremely worried. I'm just really curious about that. So, evaluating i32 load. Oh, hold on. Never mind. I was looking at the wrong part of the file. Stand down, everyone. Stand down. It's all fine. I was just scrolled down too far and I got overexcited, but that is correct. It should be 0 and 0. Okay, fine. All right, don't stop overreacting, everyone. It's all right. Okay, so load needs a store. What is it? Offset value. I know for all of these other operations, I just gave them totally generic, names like left and right, but for some reason it's now become important to give this a proper name. So again, let's make sure that we know what the heck we're talking about here. Right, so Chris is asking, could assert return evaluate sub-expressions rather than knowing how to invoke? Well, the thing is, I don't know that invoke is even... Right, okay, so I mean, clearly I could implement this as an expression that can be evaluated. I'm just not sure that it is one. I think it might just be part of... I'm making a very half-hearted attempt to segregate the evaluation of WebAssembly expressions, which is this stuff, from the actually separate syntax of test scripts. So all this stuff that we're seeing in the... I think module clearly has to be part of WebAssembly syntax, but I actually just don't know. These actions, invoke and get, that exist at the same level as assert return, like, I don't actually know whether this is legit WebAssembly syntax or if it's just part of the syntax of these test scripts that have, 7 pre-baked assertions and also these couple of actions that can be plugged into those assertions and also apparently can be commands in their own right outside of the context of it. So I could do that, But for the moment, I'm trying to have a bit of separation of church and state until I discover that this is legit WebAssembly syntax, in which case I will gladly push it down into evaluate, and then I'll just get assert return to evaluate whatever expression is passed in here. It's just partly laziness, but also partly hygiene between what's actually WebAssembly and what is just this invented script syntax that the reference interpreter uses for all of the acceptance tests that it ships. So, okay. What do I actually want to do? Well, I can get my... If I do value pack... I guess it has to be in an array. Value pack L less than. Then that gives me my sort of packed string. But then I've got to get that into memory bytes somehow. This was the thing I was worried about. I don't know how many characters in it is. Good night, Chris. Thank you for coming. Thank you for all your help. I'll see you next time. The only thing that I can think of is to temporarily set the encoding to ASCII 8-bit, because then characters and bytes coincide. Yeah, screw it, let's do that. I don't know why I always try to type US ASCII. I don't know. That's just how I think of it. So I'm going to want to force it to be ASCII 8-bit for the duration of this. Again, I don't know if this is right, but this is just my intuition, is that all of these operations that take character offsets, if I tell it that the string is just every character is a byte, then it'll all work fine, and then I just have to force the encoding back afterwards. So I think I have to say memory bytes square bracket offset comma 4 equals, I mean, I guess this is just, well, I was going to say pack string dot length, but I'm just going to inline this, so tough luck. So that's my plan. I don't know if there's a better way than that of doing it, but I'm just powering through. Well, he says. Not doing a very good job of powering through, am I? Calling something on string, no method error. But unfortunately, the string is so long. Why don't I temporarily set page size to be something more sensible? Define method ampersand for huge string. Oh, okay. Well, yes. Good point. What's the return? What's the result of this instruction? Because at the moment I'm returning that string, which is, I mean, I assume that the result of this is going to be 0. Let's see. Execution. Memory instructions. Stream nearly dies. Where's store? Load. Store. Right. Well, I mean, the whole notion of return value is a little bit incorrect because there are no return values. All of the operations that return something just pop something onto the stack, push something onto the stack, and I haven't implemented that yet. So let's just return 0, and then at least, because this is being invoked, nobody should care about what the result of this is, so it should be fine. Okay, invoke. Oh, that test passed. Wow. I was not expecting that. Is there nothing in string? No. Okay, all right. Nothing else about encoding, so I'm just going to have to live with this. So this is implement the i32 store instruction, and I will do a bit of commentary here. I'm forcing the string encoding to be ASCII 8-bit so that we can refer to the correct byte offset within the string. If it was UTF-8, then there's a risk that there might be a multi-byte character in the string, in which case our offset, which is in bytes, would be incorrect. I don't know any way to, although string byte slice, is that what it's called? Yes, allows you to read a substring at a given byte offset and length. I don't know of any similar operation which allows you to replace a substring in the same way. So I've gone with this hack instead. So I mean, these are literally the same implementation, aren't they? Because our representations of floats and integers completely coincides, this is actually doing exactly the same thing. Oh, so now this is trying to do 64-bit. Okay, well, it's a good job that we had that exception in there. Implement the F32 store instruction. Again, this is exactly the same as the implementation of I32 store, because our internal representation of 32-bit integers and floats is identical. So clearly this is trying to use i64 load. So now let's say case, well, let's say format. Format equals case bits. In 32, it's L less than. In 64, it's Q less than. And then that'll raise an exception if we get an unrecognized length and a bit number of bits. Wow, this is all working. Okay, so this same thing goes in here. Oh. Crap. Expected 0 got massive number. Oh dear. And as usual, it's hard to tell which one this is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the 13th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, it's because hold on. Why didn't this raise? Like this, it's because this reset isn't working properly. It's not correctly storing this, but this should be... Oh no, okay. It's because these functions have got the same names, or rather this one has got the same name. And because we're just pushing these functions onto an array, and then we find the first one that matches, this one is winning. So this is not even getting called because this one is sort of gazumping it. So I think what I need to do is when we start a new module, I think these things need to move into there, I think, although I'm not sure about the scope of those locals. Yeah. Oh, well, the instance variable is fine. But this needs to be nil on the outside there. But then when we come into a new module, we need the memory to be nil, we need the functions to be the empty array, and then I'm hoping what I'm going to see now is an exception about I don't know how to store a 64-bit integer because it will be using the right version of that function. Yes, there we go. 342. Right, okay. So, well, I mean, I'm going to get my free commits, implement the i64 load instruction, implement the f64 load instruction, and then this is going to be, well, I actually don't need to move this memory, do I? So in the interest of making that commit more focused, let's say reset list of functions when defining a new module. This prevents old functions with the same. This prevents functions defined in earlier modules overriding the implementation, or let's say shadowing the definition of functions with. This prevents a function defined in an earlier module from shadowing the definition of a function with the same name in a later module. It's amazing that hasn't been a problem until now, but I guess, you know, we've just never been in a situation where function names get reused with different implementations across different modules within the same file. Like maybe if we'd been concatenating all of these test scripts together and running them in one go, this problem would have come up much sooner, but as it is, we kind of got lucky until now. Okay, so yes, we've got the exception that I want. So now, similar kind of deal here, copy paste, sorry about that. But this time it's format bytes, or maybe it's like length. I don't know, why am I doing that? I'm anticipating the fact that I'm going to have to do this here. Although it's really just bits divided by 8. So maybe that's fine. Oh, and this needs to be format. Yes. More tests passing. And now I just need to copy this wholesale for F64 store. Oh! Amazing. Okay. So, so this is i64 store. And then I'm also going to need to remove this from test.sh because now float memory should be working. I always forget to, last time I did this, Tekken was here to remind me to add things onto the end here when I get them working, because obviously that's the whole point, but I'm not clever enough to remember to do that. Okay. Excellent. So, I mean, I think I'm going to stop there because, well, you know, I've been going for ages. So, but now I think we're definitely a step closer to being able to execute this file. I think maybe we're going to need, maybe that gives us everything memory-wise that we need apart from, oh crap. Memory. So memory data, we've almost implemented this. We just need to have support for this kind of multiple strings concatenated together, but that's not too hard. In fact, I would go so far as to say it's easy. And then it's just load and store instructions. We don't have support for this offset equals thing, and I'm not sure what that means. I mean, I can guess what it means, but like, why is it not just a, I32 const 0? I've never seen this syntax before, so that's slightly mysterious, but it looks like that we've basically got all of the memory functionality that we need for this file. But there's plenty of other stuff in here that we don't have. So yeah, I've got conditionals and, well, is it just conditionals? No, so it's got block and loop, and yeah, this is the stuff we looked at before, locals. Okay. So yeah, I think next time what I'm going to have to do is kind of dive down into, I'll run the tests on GitHub. That's what I always do at the end, isn't it, to celebrate? So I think what I'm going to do next time is, well, probably try and just get the parts of memory that file needs done without getting too distracted by trying to get the memory.wast done, because that seems to be exercising every possible feature of memories, which we don't need just for this float expressions file. And then see if I can do the same with the conditions and the block and the loop and stuff, and just try and do like a minimum viable version of each of those. Oh, feels good. So yeah, that's what I'm going to do next time. As always, I'm incredibly grateful that anyone is watching this, so thank you for watching. I feel good about this one. I think stuff has gone okay. I've been a little bit more focused. I've made clearer progress, not tons of progress, but I was sort of dreading this memory thing because I didn't know anything about it. But now it feels like, at the very least, I've broken the seal on it and I kind of know where we're going with it. So yeah, a good stream's work, I think. So I will say bye, and I will see you on the next one.